Hello, friends. Once again, welcome. In our next clip, we want to look at a question on errors and approximation. And here is the question. We could be asked, what is the percentage error in using 0.3 recurring when there's a dot on top of a digit like what we have there, we say it's recurring uh, as 0.3. So let's take note that 0.3 recurring is actually 0.3333 on and on and on up to when we do not know, which is actually, if you work out, there's a procedure for working out a recurring decimal and converting it into a fraction, you'll find that 0.3 is actually 1 over 3. That is the exact value. Okay? Now, on the other hand, now 0.3, just plainly as it is, when converted into a fraction, is actually 3 over 10. So in essence, this question is asking us to find or calculate the percentage error in using 1 over 3 as 3 over 10. Of course, you know from topic of errors is that whenever there's a difference between a measured value and the actual value, then that difference is what is called the error. So like you can see here, we have a third and a 3 over 10. These are definitely two different numbers. So there's a difference between them. So that difference is what we are calling the error. So in this case, therefore, we'll say the error involved, error, which is at times referred to as absolute error. The absolute error, most of the times abbreviated as AE, is actually the difference between the actual value and the measured value. And we put it between parallel lines just to show that we are calculating. We're only interested in the value, not whether it is negative or positive. We're only interested in the positive value. So if you do your calculation, you'll find that this is actually our LCM being 30. So we'll have 3, and that is 9 minus 10 absolute, that is 1 over 30. The absolute error is 1 over 30. But note that to get the percentage error, we normally have the absolute error, the formula, and I would advise you to check in my other clips. I've extensively talked about calculation of absolute errors in other clips. So the percentage error by formula is over actual value times 100 to get the percentage. And of course, the result will be as a percentage. So in our case here, what is our absolute error? As we have calculated is 1 over 30. And then we divide by the actual value. What is the actual value? The actual value is the original one before rounding it off. Of course, if you have this as the recurring decimal, if you consider it as 0.3, it means you've rounded it off to one decimal place. That's why now you have 0.3, which is actually 3 over 10. So we divide by the actual value, which is 1 over 3, and then multiply by 100. So this translates to 1 over 30 times 3 over 1 times 100. So you can see when you cancel out here, so the percentage error is actually 10%. And this is the solution to our question. Thank you once again for your audience. But before you go, may I give you a problem? Can you solve a problem? This, like if you replace this, what is allow me to write it there. What is the percentage error of using 0.7 recurring truncated, is a term there, truncated to decimal places. When truncated to 2 decimal places, what is the percentage error in using 0.7 recurring when truncated to 2 decimal places? Please let's engage in the comment section by giving me your answer, and I'll be glad to respond to you. Have a nice time.